An interesting integral. Now, let me do two methods for this integral. The first method is obvious that split this integral into two. The first one is from 0 to half pi and e to half x times square root sine x and cosine x dx. The other one is plus integral and e to the half x and square root sine x dx. Good. And this one, let me see. For this one, I try the derivative of square root of sine x. That would be equal to 2 square root of sine x times cosine x, right? And times the dx. So I do have cosine. I do have a square root sine. I don't have a 2. So you multiply 2. So this one is equal to integral from 0 to, if I multiply 2, then it's okay. This will be d sine x, right? Yeah, it's equal, because this one is equal to this. After multiply 2, you get this. And this one I keep as is for a while. E to the half x square root sine x dx. Now this I can use by parts. Once I write something like UDV, I can use by parts. So this is 2 e to the half x square root sine x. Right, that's a UV minus VDU. V is this. Du is 1/2 e to the half x dx, right? Then plus the remaining, this is e to the half x square root sine x dx. Okay, so 2.5 cancel out. Remain the same thing as this one, so this one will cancel with that one. So the integral becomes, wow, I always forget this. 2 half x square root sine x from 0 to half pi. So this one is equal to, this is 1, right? 1, therefore 2 to e to the quarter pi. Yeah, minus 1. Okay, that is the answer for this integral by method 1. Now method 2, method 2. Now look, when I see e, when I see the function, exponential function, it is quite special because the derivative will be this. The derivative of this function is itself. Therefore, can we think of e to half x times a function? Then the derivative of that will be equal to half e to half x times f of x plus e to the half of x times f derivative of x, right? A product rule. So we take the common factor out. This is a half f of x plus f derivative of f of x. F derivative of x. Now, can we think a function f of x such that half of it plus its derivative is equal to this? Okay, half of this plus its derivative is equal to this. Then the integral is a very obvious, the result. So can we think this one must get involved with the square root sign, because after the derivative you have a 1 over square root of sine x. So we suggest that it's equal to something like this. Okay, then f prime will be 2 sine x, right? And cosine x. Yeah. So is this plus this is equal to that? Well, almost. Almost, right? I don't have a 2 here. So in other words, let me make adjustment for f of x equal to 2 square root x. Square root x. Huh? Then f prime will be equal to square root sine x cosine x. Wow, that is exactly what I have. Okay, this plus, well, this times half. Don't forget, this times half plus this is exactly equal to that. Wow, isn't half of fx, half of this plus this is equal to that. Therefore, I finally understand that is e of x, and f of x is 2 square root derivative 1. Okay, all right, then this is equal to 2. This derivative integrate is equal to square root sine x from this to half. What? Wait a minute. I forget e. So this one equals to e to the half of x times 2 sine x from 0 to half pi. Yeah. So that one's equal to 2 e to the quarter pi. Yeah. Same result as a method 1. Okay, it's a very, very good, it's very good training for the basic integrations. Thank you.